Okay, quick pop quiz. What's the difference between place value and face value? Or what are stomata? If you're drawing a bit of a blank right now, trust me, you are not alone. Today, we're going to find out just how much of that stuff we learned back in school actually stuck around. So the question is pretty simple. Could you still pass a sixth grade final exam?
And this isn't just some made-up quiz. Nope. We have an actual sixth grade final exam on hand. We're talking math, biology, physics, and chemistry. Now, the questions might look simple on the surface, but the ideas behind them, well, they're the absolute building blocks for how we make sense of the world. So let's see how strong those foundations really are. So here's the game plan. We'll kick things off with the universal language of math, then jump into the rules of life with biology. After that, we'll get into some physics and try measuring everything, and we'll wrap up with the science of change, hello, chemistry. And then, of course, the big reveal, we'll see how we all did. You ready? Let's go. Look, the goal here isn't really about getting a perfect score. It's more about reconnecting with those big, core ideas that kind of shape our reality. Let's see what we can dig up from the memory banks. All right, let's dive into our first round, universal numbers. You know, they say math is the language of the universe. But as we're about to find out, different cultures can have some pretty different dialects for speaking it. Here we go, first question. And the answer might just depend on where you grew up. 1 crore is equal to how many thousands? I'll give you a second to think on that. It's a big number. The answer is 10,000 thousands. Now, what's so cool about this is that it's not just a math problem, it's also a cultural one. A lot of us are used to thinking in millions and billions, right? But the Indian numbering system uses lakhs and crores. It's just a great little reminder that even something as fundamental as numbers can have a local flavor. Okay, let's try to pull this one from the dusty corners of our minds. In the number 4,324, what is the difference between the place value of the two fours? And that word place is really the key here. And this lays it out perfectly. The face value is easy. A 4 is just a 4, no matter where it is. But place value, that's all about position. That first 4 stands for 4,000, while the second one is just 4. So the difference is 3,996. It's this simple little idea that our entire number system is built on. Okay, enough numbers for now. Let's shift gears from the clean, abstract world of math to the messy, weird, fascinating rules of life itself. It's time for round 2, biology. So what does it even mean to be alive? That's really the question at the heart of biology. And the most basic rule, the starting line for absolutely everything, from a tiny bacterium to a giant blue whale, is that it all kicks off with just a single cell. Speaking of all the different kinds of life out there, let's talk lifespans. Who do you think wins in a longevity contest? A human or a tortoise? I bet you have a guess, but the actual difference might just blow your mind. Yep, as you probably guessed, the tortoise is our champion, living more than twice as long as a human. Easily. But just look at that whole spectrum. The entire life of a single bacterium can be over and done in 20 minutes. It really puts our own time on this planet into perspective, doesn't it? Now, every so often, an exam paper gives you an absolute gift. This question asks about pores and pigments in leaves, and one of the multiple choice options is chlorophyll. I gotta be honest, I was not aware that plants were getting food delivery now. Okay, jokes aside, let's get to the real answer. It's pretty safe to say they meant stomata. Those are the tiny little pores a plant uses to breathe. And chlorophyll, which is the green stuff that magically turns sunlight into food. So you get a solid lesson in biology and, the importance of proofreading. From the building blocks of life, let's move on to the rules that govern the physical world around us. This is physics. But don't worry, it's not the scary kind. This is all about the simple, basic quest to make sense of everything by just agreeing on how to measure it. And believe me, that quest started a long, long time ago. Before we had standardized rulers and things, people used what was, quite literally, on hand. So what type of unit do you think a cubit is? It's what we call a non-standard unit. A cubit is just the length from your elbow to the tip of your middle finger. The problem, as you can imagine, is that my arm isn't the same length as your arm. And this is exactly why we came up with standard systems like meters, kilograms, and seconds, so that scientists and engineers all over the world could actually be on the same page. So, using that standard system, let's try a quick and practical conversion.
If someone walks 3,250 meters, how far is that in kilometers? That would be 3.25 kilometers. And this right here shows you the pure beauty of the metric system. Kilo just means 1,000, that's it. There are no weird fractions or random numbers to memorize. It's all just simple, clean, beautiful logic.
And now for our final round, we are digging into the science of change. Welcome to chemistry, the absolutely incredible study of how all the stuff around us can transform from one thing into something totally new.
Let's start with a really important idea, reversibility. Which of these changes can you actually undo? Is it A, turning milk into curd, B, melting ice into water, C, stretching a rubber band, or D, is it both B and C? And you can see exactly why right here. You can melt ice into water, sure, but you can also freeze that water right back into ice. And a rubber band? It snaps right back to its original shape. Both are totally reversible. But once that milk turns into curd, well, there's no going back. So if you picked D, you nailed it.
So the real key is understanding the difference between that and a chemical change. This is a true transformation. You get a brand new substance. The change is permanent and you just can't reverse it. The test gives the example of burning petrol. Once you burn it, it is chemically changed into exhaust and energy. The original petrol is gone forever.
And that's the final bell. So tell me, how did you do? Did that stomata question get you? Or did you totally breeze through that meter to kilometer conversion?
But you know, at the end of the day, the score doesn't really matter. Place values, single cells, standard units, reversible changes, these are the simple foundations we were all given. So the real question isn't whether you can still pass the test. It's more about taking a second to appreciate the incredible, complex, and totally unique understanding of the world that you, and only you, have built on top of them. Thanks for digging into all this with me.